Hello. Today I want to talk about a homework problem that's sometimes encountered in a life contingencies class in actuarial science. So let's get started. Well, if I can get this to work, that is. Okay, here we go. We're given the following sort of problem. It's a frequent homework problem. Given that we have, in this case, 30,000 um, independent select lives and 70,000 independent non-select lives. And we're given the following survival probability functions. The select probability of a life select age 60 surviving is 0.999, and probability of non-select life age 60 surviving the next year is 0.995. So the question is, find the expectation and standard deviation of the number of survivors after 1 year. Now, the thing to remember about a problem like this and how we typically tackle this is for each set of lives, remember the lives are independent. What we can do is we can set a random variable. So let's call this X sub S for select, the random variable for a number of survivors among the select cohort 1 year, and let us X sub N be a random variable number of survivors among the non-select cohort. Now, a common assumption that we make is that each of these random variables is binomial. So for X sub S, assume binomial with N equal 30,000. Remember, these are independent. That's a common selection here, a common assumption. P is 0.999, which we did for select, and your Q, here I'm using Q to be 1 minus P rather than mortality, is 0.001. So the expectation of this variable here would be 30,000 times 0.999, which is not a very difficult calculation, which calculates to 29970. The expectation of the non-select be 70,000. 0.995, and again, that's not an overly difficult calculation. 69, 650. And then if we let's say y equal the sum of these two, the expectation of y is just the sum of the expectations. Now that's sort of the easy part and very intuitive. So the next question you want to do is, what about the standard deviation? Well, if we let random variable y, as I said, be xs plus x sub n, we know that the variance of y is going to be the variance of x sub s plus the variance of x sub n plus 2 covariance of xs xn. But remember, all of these, but all the lives are independent. In particular, these are independent also. So the covariance is 0 here. So the variance is actually going to be a simple sum. So if we look at the variance of x of s, well, that's going to be, because it's binomial, NPQ, which is in this case 30,000, 0.999. And remember, I'm not using Q for mortality here, but I guess it is. I guess it is after all. And I get the calculation of 29.97. The variance of the normals of the non-select is 70,000, 0.995, 0.005, and I get 348.25. So summing, and we're lucky it's a simple sum, I get 378.22, and then the standard deviation be the square root of the variance. It's 19.4479. So that is one way that you can attack this problem. And thanks for watching.